Quadratic equations. A quadratic equation is an equation that can be written as ax squared plus bx plus c equals 0, where a, b, and c are constants with a not equal to 0. A graph of y equals ax squared plus bx plus c is given. Use this graph to solve ax squared plus bx plus c equals 0 if possible. Now we're looking at these graphs of these quadratic equations, and look at the equations they've given us up here. First they have the graph equation, and then they want us to use that graph to solve this equation. We don't have the values of a, b, and c, so we can't do this symbolically or with algebra. So what we'll have to do is try to use the graph to teach us to solve here. Here are the only thing that's different between these two equations is that y is 0. So we have the graph of that equation, and we're using it to solve this equation where y is 0. So basically they're asking us to find on the graph the value of x when y is 0. That would be this point on the graph and this point. So those are the points -2, 0 and 1, 0. So the places on the graph where y is 0 is when x is -2 and +1. Now we're looking at this graph. This graph doesn't come down far enough to cross the x-axis, so there's no place on that graph where we're going to have an x-intercept, which means we're not going to have a solution to this ax squared plus bx plus c equals 0 equation. So here we'll just have to say that there is no solution. Solve the equation symbolically and graphically. So we know how to do this symbolically. We simply factor. We're going to factor that trinomial, and then we set each factor equal to 0 and solve those simpler linear equations. And we get x equals 5 or x equals -1. Now let's solve this graphically. Grab your graphing calculator, and what we'll do is put this in our y equals editor as if we're replacing this 0 with a y. So we'll have x squared minus 4x minus 5. When I graph that, I'll be able to see where the graph is crossing the x-axis. Those are the places where y is 0. So instead of having this equation, it's 0 equals, if we're looking at those places right there. Okay, so what we need to do is use the calculate menu right here. So second, calculate, and we want to find the 0. In other words, when that function value, the y value, is 0. Here we want to focus in on this first intercept point. So it's asking for the left of it, so we need to move our cursor to the left of it, and then we want to go to the right of it. Okay, so you can see these two arrows have appeared up here. It is going to find the 0, the place where the function is 0, between this and this. And when you hit enter for it to guess, the little cursor lands on the intercept and it gives you that point. Now, because of the approximating algorithms in your calculator, you may have where this is a little bit different, or maybe even this is a little bit different, but it's an approximation. Right now it's on it perfectly. We know that x is -1 and y is 0. Now let's go ahead and find the other 0. We'll go second, calculate again, 0 is option 2. And now we need to get to the left and the right of this point. So just use your cursor keys and we'll enter. And to the right of where we see it's crossing, hit enter. Again, you see those arrows appear. So we're going to find the 0 between here and here. Ready to guess? Go ahead and hit enter. And here we have the point 5 and a 1 times 10 to the negative 12, which is a 1 where the decimal place is moved to the left 12 times. So really this is approximating 0 for us. So our other solution is 5, like we thought. So as we said earlier, finding the solutions, we can find them exactly when we solve it with algebra, and we only confirm it graphically because this is going to be an approximate answer for us. Let's go ahead and solve this one symbolically, and then we'll confirm it graphically. So we'll use our factoring technique first. We'll have an x plus 3 and an x minus 1 equals 0. And this would be an x plus 3 is 0, and x minus 1 is 0. So we get x is negative 3 and x is positive 1. Let's go ahead and try this with the calculator. We're going to put in the calculator x squared plus 2x minus 3. There we go. Go ahead and graph. And again, we're trying to find those x-intercepts, the place where the y value is 0. So second, calculate 0. Let's find our left intercept first. So we're going to go to the left of it, hit enter. We're going to go to the right of it and hit enter. Hit enter again, and there we have our other solution there. Let's find the intercept on the right. So second, calculate the 0. Let's get to the left of it, hit enter, and somewhere to the right of that intercept, and hit enter. And hit enter again for it to guess, and we get 1, 0, so the x is 1. Square root property. Let k be a non-negative number, then the solutions to the equation x squared equals k are given by x equals plus or minus square root of k. If k is less than 0, then this equation has no real solutions. So we're going to use the square root property now to solve some of these quadratic equations, namely the type where we have no plain x that shows up. This would be an example where we would use square root property. So the first thing that you want to do is to isolate that squared term. Then we're going to take the square root of both sides, and we get x equals plus or minus the square root of negative 2, which is going to be an I square root of 2. So no real solutions, but we do have a complex imaginary solution. Let's use the square root property to solve this one. First, we need to isolate the x squared term. So we'll go ahead and add 64 to both sides. Then I need to get rid of that 5, so I'll do that by dividing by 5. That gives me an x squared equals 64 over 5. And now I'll want to take the square root of both sides. Remember to place your plus minus so that we can capture all of the solutions. We get x equals plus or minus the square root of 64 is going to give me 8, and then I have still the square root of 5 on the bottom, so I'm going to need to rationalize this solution, rationalize the denominator so that we don't have the radical in the denominator anymore. So that gives me a 8 square root of 5 on top. And square root of 5 times square root of 5 is the square root of 5 squared, which is 5. Let's go ahead and use the square root property on this. First, we see that the squared thing is isolated. It just happens to be that it is a binomial squared. So we're going to take, again, the square root of both sides. And this gives me an x plus 1 on the left and a plus minus 5 on the right. So we have x is a negative 1 plus or minus 5. So here I know that I have a negative 1 plus 5, which is 4, or a negative 1 minus 5, which is negative 6. Let's use the square root property to solve this. First, we need to isolate the squared thing, so we're going to isolate x minus 5 quantity squared. The first thing we'll want to do is to divide by 10. So x minus 5 quantity squared is 5. Now we'll take the square root of both sides, and we get x minus 5 is plus or minus the square root of 5. When I add 5 to both sides, I get x is 5 plus or minus the square root of 5. Let's study the table of squared binomials here and perfect square trinomials and see if we can eventually find a pattern and fill in those yellow blanks on the table. First off, let's start with a plus b quantity squared. This is really the formula for expanding a binomial. The work in the middle from foiling would be a squared plus ab plus ab plus b squared. And then we collect our like terms and we get 2ab in the middle. How about if we square x plus 5? The first thing would be to use FOIL. So we get x squared plus 5x plus 5x plus 25. Combining the like terms in the middle, I get a 10x in the middle. So again here, x minus 7 quantity squared. We square the first term, square the last term, and the middle is x minus negative 7x twice, because we'll have two of those for the O and the I of the FOIL method. Collecting like terms, I get this trinomial. So apparently when we square a binomial, we get this trinomial. What we want to observe here is what will the sign here be? It doesn't matter if I have positives or negatives, the sign of that last term is always going to be positive because it comes from squaring that second term of the binomial. B squared is b squared, positive 5 squared is 25, negative 7 squared is a positive 49, so this will always be a positive. So we know for sure this is going to be a positive. And where is that last number coming from? That last number comes from squaring the second term of the binomial. So I know here that I am going to square 9 and get an 81. Alright, now let's come up with a way here that we can make what are called these perfect square trinomials and then figure out how it is that they factor. So if I wanted to make this a perfect square trinomial, we need to decide how this number is related to these other numbers without knowing what's over here. So let's observe this. How is 25 related to 10 without knowing any of this? Okay, 25 is related to 10 somehow. How is 49 related to 14? How is 81 related to 18? If you look at this, if we take half of 10, that's 5, and square it, we get 25. Half of 14 is 7, squared is 49. Half of 18 is 9, squared is 81. So let's take half of -4, which is -2. We square that, and we get a positive 4. Now, how is that trinomial going to factor? It factors as x minus 2 quantity squared. What number would we put here? Going to take half of -2, which is -1, squared is a positive 1. And this factors as x, a minus because this is a minus. The square root of 1 is going to go here, quantity squared. How about this? What number would go here? Half of 24 is 12. 12 squared is 144. Now, how does this factor? The square root of the first, use the sign of the middle term. The square root of the last, all squared. Now here, this is a little different. All of these middle terms have had even coefficients. Now we have one that has an odd coefficient. We'll end up with a fraction, but we can still do it, no problem. First off, half of 3. When we say half of something, it means half times. So when I multiply the 1/2 times the 3, I get 3 halves. Now, I still need to square that number, so I'm going to square the entire fraction, and that gives me a 9/4. So here, the number that we put is 9/4. Remember, it's half of 24 is 12, squared is 144. Half of 3 is 3 halves, squared is 9/4. Now, how does this factor? The square root of x goes here. We're going to use the middle sign. And the square root of 9/4 is 3 halves. Now, the process you just learned is called completing the square. We can use this method along with the square root method for solving quadratic equations. So let's show you here solving by completing the square. We have x squared minus 2x equals 24. What we'll want to do is leave a space here so that we can add that special number that makes this a perfect square trinomial. Alright, so what number would I put here if I wanted to make this a perfect square trinomial? Half of 2 is 1, squared is 1, so I'm going to add 1. Now, you know with equations we can't just add 1 to one side of the equation. We have to add 1 to the other side as well to keep the equation balanced. So I'm going to go ahead and write this as its factored form, x minus 1 quantity squared. And on the right side, I'll have 25. Now we have a problem that's very similar to the problem that we worked here, where we have the square of a binomial equals a number, and then we use our square root method to finish solving. So that's really what completing the square is about, is making a perfect square trinomial so that it factors as the square of a binomial, and then we can use the square root method on it after that. Right now, we're ready to take the square root of both sides. Remember to put your plus minus. So I'll have an x minus 1 equals plus or minus 5. And then I'm going to add 1 to both sides. And let's simplify that. 1 plus 5 is 6, and 1 minus 5 is -4. Now, if we had solved this using factoring, where we subtract 24 from both sides and then factor the trinomial, then we would have come up with those same answers. The interesting thing is that we're going to be able to use this when we have trinomials that are not factorable. This is an example of one of those trinomials. We would not be able to do this at the beginning of the semester because we don't have any numbers that multiply to be -2 and add up to be a 6. So we'll use our completing the square method on this one. Alright, we need to figure out what number we add here to make a perfect square trinomial on the left side. So we're going to take half of 6, which is 3. 3 squared is 9. But if I add 9 to the left side, I need to add 9 to the right side. Now I have the perfect square trinomial, which I know factors as the square of a binomial. Now I'm ready for the square root method. I'm just going to take the square root of the left and the right, remembering my plus minus, and I have x plus 3 equals plus or minus square root of 11. So finish solving for x. X is negative 3 plus or minus square root of 11. And that's the best we can do for that. We definitely would not have been able to solve this by factoring, but at least we do get some kind of irrational solution for the equation in the end. Let's try this one. Again, we have to make a space here so that we can complete the square. I'm going to take half of 3, which is 3 halves. I'll square that. That gives me a 9/4. So I'm adding 9/4 to the left side, and I also have to add it to the right side. So for my left side, I have an x minus 3 halves, quantity squared is how that would factor. And on the right, I have 5 plus 9/4, which is 29/4. Let's go ahead and take the square root of both sides. Don't forget your plus minus. And we have an x minus 3 halves equals plus or minus the square root of 29 all over 2. So x is 3 halves plus or minus the square root of 29 over 2. Again, we could not have solved this by factoring, as evidenced by the irrational answer that we have at the end of completing the square. Let's try completing the square here. These can be a little tricky because you need to make sure that you have the x squared and the x on the same side, everything else on the other side. So there's a little rearranging that needs to be done first. Now we're going to take half of 2, which is 1. 1 squared is 1. And balance by adding 1 to the other side as well. So I'll have an x minus 1 quantity squared equals 5. Now I'm ready to take the square root, both sides, and I have an x minus 1 equals plus or minus square root of 5. So finish solving by adding 1 to both sides, and I have an x of 1 plus or minus square root of 5. Again, an equation that we would not be able to solve by factoring, but we were able to by using completing the square. Let's solve this equation for the specified variable. K equals 1/2 mv squared for v. The first thing that we probably would want to do is get rid of the fraction. So let's multiply both sides by 2. This gives me a 2k equals mv squared. Now I need to isolate the v squared. That means I'll want to get rid of the m by dividing it off of that term. So 2k over m equals v squared. Now I need to take the square root of both sides. Remember your plus minus, and my v now equals plus or minus the square root of 2k over m. And we can leave that formula as is. We don't need to rationalize the denominator. That covers this section, so go ahead and try your homework and let me know if you have any questions.